Hello, everyone. Welcome to another episode of Science and Technology Q&A for kids and others. And I see we have a variety of questions saved up. Where should I start? Let's see. I noticed one from Gil here. Is it possible to produce large amounts of crude oil artificially by manipulating chemical kinetics? Okay, so what is crude oil? Crude oil is these chains of carbon atoms with hydrogens connected to them in molecules. And the basic point is that, not necessarily chains, also rings and so on. Basic point is that energy is being stored in these chemical bonds. So roughly what's going on? We've got a bunch of atoms, carbon atoms, and those carbon atoms they have forces of attraction between them, which we can think of as chemical bonds. Those forces of attraction come from various effects, mostly kind of complicated physics effects associated with quantum mechanics. But the end result is that we can think of like two carbon atoms want to be stuck together because they kind of share electrons between them. And what happens in something like oil is that you've got these carbon atoms are arranged with a collection of these bonds in which there's sort of energy stored in these bonds. So if you were to if you broke this molecule apart, you would release energy. Okay, where did this all? Let me try and describe how this all started. I mean, where does oil come from? It is the results of plants that were growing in the Carboniferous period, whatever, 300 million years ago, maybe, that were where rock formed on top of that, sediments got piled up on top of that, or lava came out on top of that, and so on, and there was sort of a big pile of plant material that was crushed, and that's the oil that we drill out today. Now, why is there energy there? Well, there's energy there because plants have this whole mechanism, all living organisms have these mechanisms for getting energy that they can use for their own operations, so to speak. And the energy ultimately comes from the sun, but it is sort of set up as something that is stored chemically inside the plant, and the way that works is the plant uses photosynthesis, uses this process of taking light from the sun into these little things inside cells in plants called chloroplasts that have a substance called chlorophyll in them. And through processes that are still not completely well understood, a photon of light comes in, and it causes essentially in the end, it's going to cause chemicals to be produced that have energy that came from that photon of light from the sun, but that energy is now kind of trapped inside the chemical bonds that exist in these chemicals. And those are ultimately the chemicals that turn into the oil that we have today. So essentially what we're saying is that we're using energy ultimately from the sun to put together these molecules which have sort of energy stored in them. And when we come to use the oil and we, for example, burn the oil, that process of burning, adding oxygen and so on, releases the energy associated with those chemical bonds, and that's how we get energy from things like oil. Now, the question is, can we just make those molecules ourselves? And the answer is absolutely yes. But it's going to take us energy to make those molecules, because in the end, those molecules are storing energy that we put into them. So yes, absolutely, we can make molecules that are just like crude oil, but it will cost us energy to do it, and then all that will happen is we'll get that energy back out again. Now, you can say, well, could we at least use that as a way to store energy? And the answer is, well, yes, in principle. We're not particularly efficient, I think, at doing the chemistry to store energy. I mean, chloroplasts in plants are very efficient at taking light from the sun and turning it into chemical energy. We don't have as efficient a way to do it. And so it's kind of like, well, might as well use the plants that were around 300 million years ago to do it. One can imagine, in terms of taking energy that comes from light from the sun and turning it into other forms of energy that are more useful to us. For example, photovoltaic cells, solar cells, are doing exactly that kind of thing. They're turning light from the sun into electrical energy, which we can then potentially store in a battery. Battery is using electrochemistry to kind of store energy so that we can use it again later. So I think that's now the question of what the actual molecules that you get in something like crude oil are like. That's a somewhat complicated story. You know, if you go to a gas pump, like in the US, you'll see that it says something like, oh gosh, I proves I don't fill up my car with gas often enough, but things like 95 octane will be a sort of thing written on a pump. And that is a representation of the size and structure of the molecules that are in the oil, that are in the gasoline that you might be putting in your car. And I think on most gas pumps in the US, they kind of have a footnote that says, you know, it says 95 octane or something, and then it says footnote, using the R+M/2 method. I think that's what they say. And that's a way of answering the question, what does that 95 actually mean? And it's a question of how big is the molecule, how many rings does it have in it, how many kind of sort of compact bonds are there in that molecule that store energy that your car could potentially use to run off. Now, it turns out that when this oil was formed, okay, I missed a piece of that story. When the oil is formed, it starts with the plants, but then there is, how does this work? There's a chemical process that causes one to get different sizes of molecules depending on the precise conditions and pressure and temperature and so on at which this oil was formed. And I know what happens is that in different parts of the world, there are oil reserves that are, you know, underground in different places. Famous one is the West Texas oil reserves. There are ones in Saudi Arabia, places like that. But the question is, what is the distribution of sizes of molecules that exist in these different oil reserves? And I believe the sort of famous kind of oil is West Texas Intermediate, I think it's called. And that particular kind of oil has kind of a good mixture of different sizes of molecules in it, from ones that are really long molecules that are suitable for things like making plastics and tar and things like that, to ones that are really short molecules that are suitable, I guess, for aviation fuel and things like this. And I think that so in different places, different conditions caused the details of the oil molecules that were produced to be somewhat different, and that has an effect on what kind of thing the oil that's pumped out from the ground in different places can be used for. And typically there's a process, fractional distillation, where you take the raw oil that's been pumped out of the ground, and you have a kind of column that breaks down oil. The stuff that sort of goes higher in the column is the lighter oil, and that's the one with smaller molecules. The one with larger molecules stay lower down in the column, and that's how you kind of can break apart these things that are useful for cars and planes and making plastics and things like this. So I thought that was going to be a simpler question to answer. That's an attempt to answer this question of kind of how oil, sort of the chemistry of what's happening with oil. I mean, there are all kinds of things one can imagine. You know, could you make a bacterium that would make oil, just like you can have bacteria that have genetic specifications so basically what biological organisms do is their genomes specify how to make proteins. Proteins are sequences of amino acids. Amino acids have nothing to do with oil as such. So if you want to have an organism make something like oil, you have to do it as a kind of secondary thing. You can't have it directly make, what organisms directly make is just things out of proteins. But proteins can do things like, for example, they can have, you can have a collection you can have a protein that folds itself up and makes a little cage, and a cage which is of just the right size to fit a particular kind of atom. Like, for example, in hemoglobin, that's used to transport oxygen in our blood, the protein that is hemoglobin has a cage which is just the right size to fit a single iron atom inside. And that iron atom, there's enough kind of random iron atoms lying around that there'll be an iron atom that finds its way into that cage, then it gets trapped there, and that's what gets used in the red blood cell. And same thing for, I don't know, the thyroid gland, for example. Well, no, what is it? Vitamin B12 is sometimes called cobalamin. It has a cobalt atom in the middle that gets trapped in the middle of its protein. And I suppose one can imagine some mechanism for having the right molecular shape to be able to sort of assemble an oil molecule, so to speak, by something that has been, where one's constructed the molecule using sort of a biological process to specify what the shape of the molecule should be. Nobody's successfully managed to do that. I think people have tried, and it tends to be the case that whenever you can make something sort of oil-like, it kills the organism that was making it, because it doesn't really like being in an environment where it's sort of drowning in oil and so on. So I think it's a few thoughts about that. Let's see. Well, Zayden asks, how is the distance to a distant galaxy determined? Well, okay. So first, the main way that's done is by using the fact that the universe is expanding, and so galaxies that are further away are moving away from us at higher speeds. So here's a way to think about it. Imagine that you've got a bunch of you've got a balloon, let's say, and on the surface of the balloon, you've put a bunch of dots. And then you start inflating the balloon, and the whole surface will get bigger, and the dots will move away from each other. If you sit yourself at one of the dots, and you ask the question, how fast will a dot further away from you be moving away? What you should find is that the distance that dot further away from you is moving away. Let's see how to think about this. The way to think about this is, let's say you've doubled the size of the balloon, then let's think about this. The basic point is that the universe is expanding, and we can talk about why the universe is expanding. That's a separate question, but the universe is expanding, and it has that, and it's expanding uniformly in all parts of the universe. And that has the effect that a galaxy that's further away, the speed with which it's receding from us will increase with the distance away that galaxy is. So take that as a given for now. Now ask the question, how do we tell what speed a galaxy is moving away from us at? And the answer is we use this thing called the Doppler shift. And here's how this works. One's heard, if you hear a siren or something, you'll hear it as it comes towards you, the siren will be higher pitched. As it goes away from you, it will be lower pitched. Why is that? essentially it's because if you think about the sound wave, that is the sound of the siren. So if there's just a fixed frequency, if it's just sort of, if it was a siren that was just playing one note, then what it would have is a series of compression expansion pieces to a sound wave, and normally those compression expansion etc. pieces move at the speed of sound. So you're hearing a piece of compression followed by a piece of expansion followed by a piece of compression, and those things are arriving at your ear at the speed of sound. Well, what happens is if the thing that is producing those sounds is itself moving, then what will happen is that for example, let's say it's moving towards you, then those sort of expansion, compression, expansion, and so on pieces will be squashed closer together because they are each one of them, they're all sort of coming out, they're all moving at the speed of sound, but the thing that is producing them is itself moving, and so they're all escaping at the speed of sound, but the thing that's producing them keeps on getting closer to you and sort of inserting a new peak or trough in the wave at a shorter distance than it would do if it was just moving purely at the speed of sound. So what ends up happening is that when the object that's producing the sound is moving towards you, the frequency of the sound, the distance between the peaks and troughs of the wave is smaller, and so you hear a higher pitched sound, and when it's moving away from you, the opposite happens, and you hear a lower sound. So you can kind of, you could figure out the speed that something was moving at, for example, by telling what the change of frequency was of the sound that it was producing. Okay, so the same thing happens with light. It's a little trickier because with light, unlike with sound, the speed of light is constant. This is a feature, this is kind of one of the main claims of relativity theory, is that the speed of light doesn't depend on, there isn't in the case of sound is moving through air, and the air is stationary. And if you're moving relative to that, then there's still fixed air in which sound moves at a certain speed. And the claim is that that's not what happens with light. And so this Doppler shift phenomenon is a little bit more subtle in the case of light, but the same basic thing happens. When something is moving towards you, the frequency is higher of the light. When it's going away from you, the frequency is made lower. So that means if you have like visible light, if you look at different colors of light, red light has a lower frequency, it has a longer wavelength. Blue light has a higher frequency, a shorter wavelength. And so what happens is, what you might start off with as let's say white light, which is a mixture of all frequencies, you will shift that down to be on average redder if the thing that is emitting the light is moving away from you, and it'll be bluer if the thing that's emitting the light is moving towards you. So what happens is that galaxies, are emitting light, and when the galaxy is moving away from us, the light from it will be redshifted, and that by this Doppler effect, and the amount of the redshift depends on the speed that it's going at. So in the way that these things are usually described, you talk about a redshift, it's usually denoted Z, and let's say a redshift of 2. And a redshift of 2 means that the frequency of light that we're getting from that galaxy is half the way that what we would get if that galaxy were just at rest right next to us, as opposed to moving away from us. So that what one does to estimate the distance to a distant galaxy is mostly to look at the redshift of the light that comes from that galaxy. Important point about this. When you get light from a galaxy, for example, some of that light is light at very fixed frequencies. So, okay, you make an object hot at a certain temperature, it will get first red hot, then white hot, then blue hot, and so on. It will have a range of frequencies that it emits just by virtue of being a hot object. That isn't so useful in looking at this Doppler shift, because you have to kind of know how hot is the object, and to know, how redshifted is it or not. It could just be the object was colder, and that's why it was redder. It wasn't redder because it was moving away from you at a high speed. But there are things that are a very fixed frequency, and those are atomic transition lines. And so what those are when you have an atom that has electrons, you have a nucleus of the atom, you have electrons in the atom, and when the way that quantum mechanics works, the electrons in the atom can't just have any energy they want. They can't be, it's as if sort of the electrons are kind of orbiting the nucleus, and it could be the case that they kind of orbit at any distance, and they can have any amount of kinetic energy associated with orbiting at that distance. So, if you have planets orbiting a star or something, you kind of imagine that the planets can orbit at any distance from the star. And depending on what the distance from the star is, they'll have different amounts of kinetic energy associated with the speed that they're going around their orbits at. But the claim of quantum mechanics is that's not how things work on the atomic scale, and it isn't the case that the electrons can have any energy they want. There are just a fixed collection of possible energies that can exist for the electrons in an atom. So then what happens is there's that fixed collection of energy levels for the atom, and if there's a photon of light that is going to be absorbed by the atom, the way it gets absorbed is there's an electron in the atom, and that electron can absorb the photon, and then it can jump to another energy level. But it can't, if that photon is not of the right frequency to deliver exactly the right amount of energy, to jump that electron to the energy level that's sort of there waiting for it to receive it, then that photon will not get absorbed by the electron. So in order to be absorbed, the photon has to have exactly the right energy to make the electron make the transition to the higher energy level. And so that means that the so-called atomic transition line, well, okay, I can explain why it's called that, but basically the point is that for a given atom, there will be very precise numbers, there will be very precise energies of light that can be absorbed by that atom or can be emitted by the atom. And those precise energies correspond to particular frequencies of photons, frequencies of light. And so that means that in addition to this kind of thermal spectrum of just the thing is hot, you'll also see these very specific spectral lines, these very specific energy levels, very specific colors of light emitted by, for example, a star or the material around a star or something like that. And that's the way that one can determine more precisely what the redshift of a galaxy is by looking at how a particular spectral line, a particular one of these transitions, what the energy, frequency, color associated with that transition is as perceived by us in a distant galaxy as opposed to being perceived by us here. Now, the big assumption in all of this, which is that a galaxy far, far away, the hydrogen atoms in the galaxy far, far away work the same as the hydrogen atoms for us here. But we have many reasons to believe that that's true, and that you can use kind of the hydrogen atoms as a kind of standard measure of things like frequencies that will work for any galaxy. So basically the idea is you look at those transitions, those particular fixed energies, for example, for hydrogen atoms, and you say, what is our perceived version of one of those energies for a distant galaxy. And for example, it might be the case that that galaxy, it might be, I don't know, 4 times redshifted, which means that the frequency is 4 times lower as perceived by us for that particular transition in hydrogen in the distant galaxy. Now, in order to get all of this stuff started, one has to know, well, how far away are these galaxies, in fact? One has to have a normalization. We say, okay, it's redshift of 2, but how far away does redshift of 2 correspond to? And that's what Edwin Hubble figured out in the 1920s in the discovery of the expansion of the universe. What he essentially assumed was that if you've got a galaxy, the overall amount of light produced by that galaxy is always the same. Or at least on average, it's always the same. For a galaxy, there exist galaxies of a certain size. Well, okay. Assume that you had identical galaxies, but of course there's a range of different sizes of galaxies. But assume you had an identical galaxy, it will produce a certain amount of light. The further away that galaxy is, the less light we will receive from that galaxy. So the reason for that is just that the light from a galaxy is going off in all directions, and the further away we are, the fraction of that sphere of all the directions the light can go in, the fraction of that sphere that is kind of our telescope will get smaller and smaller the further and further away we go. So the intensity of light from the galaxy will fall off like the inverse square of the distance from the galaxy, roughly. And so that's a different way of working out what the distance to the galaxy is. Now, independent of the redshift. So what Hubble did was to connect redshift to perceived distance based on brightness, more or less, of galaxies. And to determine that, yes, it's really true that the perceived brightness of galaxies goes down as the redshift goes up. Those galaxies are further away. And then by sort of fitting all of those pieces together, one concludes that, yes, the universe is more or less sort of uniformly expanding. Now, in more recent times, there are sort of more precise efforts to know what the distance to a galaxy is by looking at, to normalize this connection between redshift and distance to galaxies. And there's a lot of effort to try to calculate the expansion rate of the universe and so on, the characteristics of the expansion of the universe by comparing essentially the brightness of galaxies and the redshift of galaxies. And it gets kind of tricky because one wants to have sort of a standard candle that is a thing that's always of the same brightness in a galaxy. But that's a bit hard to achieve because, for example, different galaxies can be different sizes. If you have a supernova, an exploding star, you can kind of assume that there will be, there's a certain uniformity to the way that exploding stars work, and that will be the same in any galaxy anywhere. It's a little tricky because galaxies that are sort of made from the rubble of previous, or even stars made from the kind of rubble of previous stars that have exploded, they have somewhat different elements in them than the earlier stars, because the process of going through and making a star and having it live its, multi-million year or billion-year life, and then having it explode in the supernova, that whole process causes different elements, different chemical elements to be made, which can then be used in the next generation of star. So there's some trickiness in figuring out exactly whether one has kind of a really truly comparable kind of way of working out the brightness of galaxies and so on. But that's the rough way that one figures these kinds of things out. The thing that has become clear in recent times, it's kind of a subtle thing, just what is the expansion rate of the universe? Is the universe getting progressively faster in its expansion? Is it progressively slower in its expansion? Or is it kind of going to get to the point where eventually it's just coasting in its expansion? And the question of what's going to happen, one can try and work out by looking at this, what is the actual expansion rate as measured by looking at distant galaxies. one can also work out what will one expect based on the equations of gravity and the total amount of matter that one knows is in the universe and so on. And the end result here is that there's some kind of complicated mismatches between what's observed in the expansion rate and the amount of matter that seems to be in the universe. And that's what leads to this idea of dark energy, which is essentially negative mass matter, that matter that has gravitational repulsion rather than gravitational attraction. One hasn't explicitly seen it, but kind of to make the calculations work in the standard theory of gravity, one would have to have some of this dark energy in our universe. Whether that's really how things work, I'm unconvinced, and I think our physics project probably has some things to say about this, although it's kind of difficult to actually trace that through to get to the point where one has a definite statement to make. But anyway, so a few thoughts on how one measures distant galaxies. Let's see. Oh my, there's a question. What industries do you think will be most disrupted by ChatGPT, Midjourney, AI applications, and so on? I think I talked about this a little bit before. Maybe, well, just say a little bit about sort of what's happened in the kind of current generation of generative AI. Sort of the big thing of the last month or so has been ChatGPT, which is a text-based generative AI system, and also Dall-E and Midjourney and so on are image-based generative AI systems. What do these things do? The goal is to make either text or images that's kind of like stuff that's out there on the web or elsewhere, but is stuff that is specifically responsive to some particular prompt that's given. So in the case of text, you might say, so you might have a prompt where you start off a piece of text, and then what ChatGPT is at some level trying to do is to complete that piece of text in a way that is kind of what one would expect based on what's out there on the web. So if you say, the best thing about AI is its ability to whatever. Well, let's say the best thing about AI is its. And, there's a good chance the next word will be ability. And we can know that because if we look through billions of web documents, we'll find that, yes, the next word is most often ability, for example. And so what ChatGPT, for example, is doing is it's saying, given some prompt that you gave, like write me an essay about this, that, and the other, then what it's going to do is it's going to try and fill in what will be the most likely, or what would be a possible completion that is consistent with the kind of thing that it's read on the web. And of course, it will just make a lot of stuff up because it will have read on the web. Let's say you ask it some data about some particular thing in the world. It will have seen that data about that kind of thing in the world is usually attributed to, I don't know, the US Census Bureau or something like that. So it'll confidently write down, according to the US Census Bureau, because that's what it read from elsewhere, the number is blah, 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 blah. But it made that number up. It just was making up a number that was kind of consistent with what it's seen elsewhere. Now, of course, one could be lucky, and that number could be something that it explicitly saw, the number for that particular thing, the population of the US is, or whatever. It could have seen that particular, it could have seen the sentence, the population of the US is, and seen a number that came after it, and it could have somehow picked that up and be filling that in the thing that it's generating for you. What tends to happen is there's a notion of a temperature parameter for these completion systems, which kind of says how much jiggling around there should be at the end. If the temperature is 0, then what will happen is it will have some way of working out what's the most probable next word that will occur, and it just says, here's the next word. Actually, if you do that, if you set the temperature parameter 0, you'll find even with the fanciest, ChatGPT, GPT 3.5, whatever system, that it often gets itself in a loop. it often starts just, it comes up with some words, and then it's just like, it just says, the cat sat on the mat, sat on the mat, sat on the mat, sat on the mat, etc., etc., etc. It just loops. If you give it a little bit of randomness, a little bit of jiggling, it'll not do that. And that randomness, what it's done is it's figured out what's the most likely next word, what's the second most likely next word, what's a ranking of the likelihoods of different words. And if you don't always just obstinately pick, oh, I want the most probable one each time, and the probability, the spread of probabilities may not be very great, and you allow it to go and dig deeper, then it will produce something which is does not have sort of get stuck in loops and things like this, and it ends up sounding much more human, and it has a certain degree of kind of unexpected creativity, one can call it, from the fact that it's just randomly picking between these different words. And so, for example, if you regenerate from the same prompt in ChatGPT, you'll often get different results. Sometimes the only results it can give you are ones which corresponded to some particular set of things that it had seen before that were responsive to your prompt. And however much, there's only one thing in the queue, basically, that could be pulled off. It's not like there are lots of things vying for being delivered as the next word. One of the surprising things about something like ChatGPT is it's writing, that big essay that it wrote, that's a very coherent essay, was written one word at a time. And what's happening is each new word that's put down, that becomes sort of an extended prompt that's used to figure out, well, what should the next word be? It's not thinking to itself. It's not kind of taking a step back and thinking, how should I lay out this whole essay? It's just putting down one word at a time. And it's using the fact that it's seen these patterns of how things get put together. And it's then emulating those patterns. And we could talk a little bit about what the kind of the deeper idea of the emulation of those patterns is, and how one should think about that. I'm not sure it's yet very clear. I've thought about this a little bit myself, actually, well, I can say something about that. Okay, so how does something like ChatGPT work? The first thing it does is, well, it uses a lot of kind of mathematical, numerical kinds of ideas. The first thing it has to do is it's dealing with words. Words are not numbers. You have to somehow turn words into something like numbers. And that's done by using so-called embedding vectors. And what's being done is you take a word and you're going to turn a word into a list of 1,000 numbers. You say the word cat is this list of 1,000 numbers. The word dog is another list of 1,000 numbers. The word oil is another list of 1,000 numbers. The word jump is another list of 1,000 numbers, and so on. And the idea is to make it be the case that those lists of 1,000 numbers are such that the numbers are fairly close if the words are close in meaning, and they're far away if the words are far away in meaning. And so in order to get those lists of numbers, the way you can do that is you can kind of look at a given word and you can see where does that word occur in context. If you see that you can substitute, you can either say, the cat sat on the mat, the dog sat on the mat. Something sat on the mat, so to speak. And the fact that those two words often occur in the same context means that cat and dog are somehow similar, and you can use that context to find the numbers that you can use to represent these words. So the first step is words are turned into vectors of numbers, collections of numbers. Actually, it's slightly subwords. If the words are long, they're broken into sort of tokens that aren't the complete word. And that's why, for example, you'll sometimes see ChatGPT make up a word, because it's able it creates these tokens, it smooshes the tokens together, and there's a new word. It does that a bunch when it's trying to generate programming language output and so on. But okay, so then what happens to that? Well, the ultimate operation of the system is you give it a list of a certain number of tokens. That is your prompt. its goal is to add sequentially one more token, another token, another token, another token, and so on. Each time doing it according to kind of what it's learnt from reading the web and a bunch of books and things like this is the typical sequence of what token follows, what token follows, what token, and so on. So there's sort of a question of, okay, so how does it actually figure that out? Well, it has a whole bunch of layers of what it's roughly doing is it has these things called attention layers. And what they're doing is they're saying the token you're about to put down, which previous tokens does it depend on? Does it depend on the most recent token? Does it depend on the one 5 steps ago? Does it depend on the one 10 steps ago, and so on? It has kind of a pattern of which steps ago does this token depend on. It's kind of like in a sentence in English, you might have a subordinate clause. You know, the black cat sat on the very dirty mat, and you know the cat and the mat are kind of connected as things that are kind of related to each other. The fact that the cat was black, the fact that the mat was very dirty, those are kind of footnotes to what's going on. And so you really kind of want, in order to determine that it's going to be a mat that the thing is sitting on, so to speak, it's going to, you know, what was it that was sitting on it? Well, it's got to jump back many words to find that it was the cat. And the attention layer is all about kind of figuring out how many words back you have to look to sort of know what's going on. Okay, so there's the way that the system works is it's looking back, it's figuring out which pieces are important. Then it's saying, okay, given that, given what was there before, what should I put down next? And what's happened is it's sort of figured out what is the kind of typical average thing that happens based on having seen billions, trillions of characters, trillions of tokens of text gotten from the web. And so you can ask the question, well, it could be the case that the next token to put down depends in detail on the particulars of every token that were there, whether it's a token for a cat, for a token for a dog, et cetera, et cetera, et cetera, that it can depend on the particulars. It could also be the case that there are some more global kind of, I've been thinking of them as sort of semantic laws of motion, some more global way of saying, if you've got things that are sort of, that have a collection of meanings that are sort of, that have this sequence, then the thing you get next is something which is sort of at this place in meaning space. You can think about these vectors of numbers that represent these embedding vectors for words as defining points in space. If they're length 1,000 vectors, it's 1,000-dimensional space, which is kind of awkward to deal with. We could think of a very simplified model that won't give us very good results, where we say, oh, it's a 2-dimensional space. And so, you know, cat is at this position, dog is at this position, and so on. You can at least make pictures like that using this technique called dimension reduction. And like in Wolfram language, you can use feature space plot to make pictures like that of sort of how words are arranged in this meaning space. But so the question is, are there sort of generic features of how one moves around in meaning space as one moves through a sentence and so on? Don't know the answer to this yet, but I kind of suspect that there are. And I kind of suspect that there are things we haven't ever noticed before that are kind of patterns of how the sentences we form end up sort of having pieces that have meanings that fit together in much the same way that when we form a sentence and we ask about its syntax, you know, its subject, verb, object, and so on, that there's a definite form for the grammar of the sentence. So also, I suspect there's a definite form to certain aspects of the flow of meaning in a sentence. But it's more difficult to understand that. And Whereas in grammar, one can say, oh, there are nouns, there are verbs, there are these kinds of things. What exactly the semantic categories are, the categories associated with meaning that one can also sort of put together in those definite ways, I don't yet know. But I think that that's kind of roughly what's happening, is that ChatGPT has kind of learnt these kind of these sort of patterns of flow of meaning, and that's what it's really putting down. I noticed comments here from Krista about asking about integrating Wolfram Alpha and so on with ChatGPT. Yes, it's a very lovely thing. I'll probably write something about this very soon. Wolfram Alpha is a very different story. What it's doing is very different from what ChatGPT is doing. ChatGPT is, it's taken what's on the web, it's smooshed it up, it's turned it into something where it can make stuff that is statistically similar to the web as a piece of text. What Wolfram Alpha is doing is it's taking some piece of natural language input, it's turning it into this precise symbolic computational language, then it's using sort of precisely set up data and algorithms and so on to compute the results from that precise symbolic computational language. And so, you ask it, what's the distance from place A to place B on the Earth? It knows the coordinates of those places. It computes the great circle distance, and it tells you the result. Whereas what ChatGPT will be doing for something like that, and is saying, well, I've seen something roughly like that on the web. Let me kind of extrapolate from what I've seen on the web and make something which is statistically similar to what I've seen on the web. And that usually is a 4-digit number that I see. Oh, I'll make up that number because that's how it works. And what it puts there may be complete nonsense. It's worth realizing you can ask ChatGPT to write fiction. You can ask it to write nonfiction. You can ask it to write a persuasive essay about all kinds of crazy things, and it'll make up just amazing things. I've used it, and I have to say, I asked it to write an essay about why a wolf is the bluest type of animal. And it confidently starts writing about how, well, blue wolves are not usually considered blue, but it is in fact the case that wolves there can be very blue wolves, and it gave a Latin name for a possible blue wolf, and it said it lived in the Tibetan plateau, and it was like going on and on about blue wolves. And it had a whole theory about coloration patterns based on the way that it talked about structural coloration. I didn't look all this stuff up, but I was reading it, and it's like, oh, okay, maybe there is a blue wolf kind of thing. I did check a few things, and they're just complete nonsense, just completely made up, which was sort of brilliant on the part of ChatGPT. It is statistically like what I would expect to see, but not actuality, so to speak. Very different branch from what you kind of get with Wolfram Alpha, where if Wolfram Alpha says the answer is this, it really is that, because it was able to turn what you asked into something computational. It could compute the answer, get the result, gives you the result. Now, it turns out to be possible to knit these two things together, actually in a very simple way, in a sense. You can literally ask ChatGPT, what facts did you have? What questions could be answered from the essay you just wrote? And it says, oh, what's the color of this kind of wolf? What's the whatever? And then you feed those questions that it generates into Wolfram Alpha, which will then either understand the question and tell you what the correct answer is, or will say, I don't understand this question. Then you take the results from that, you take those things, you feed them back to ChatGPT, and it will then rewrite its essay, having corrected the things that it got wrong. So that's a kind of an example of a workflow of kind of integrating sort of precise computational knowledge with essentially statistical text generation that ChatGPT is doing. And I think that combination can be quite powerful. It's probably even more powerful when you're doing that precise computation on things like data inside a company and things like this. There's all sorts of stuff to work out there. But I think some interesting things will happen there. I think it's in ChatGPT, it's definitely don't do your math homework with it. It produces this amazingly convincing sounding stuff that's just completely and utterly wrong. I mean, it's not like oh, the thing's dumb and the people who built it are dumb. Not at all. It's a very wonderful piece of technology. It's just that the thing it's doing is to make statistically plausible statements based on what is out there on the web and other things. And it just turns out that it isn't enough to make statistically plausible textual statements. That there is something that has been achieved in kind of the things that we've done in sort of algorithms and science and mathematics and so on, that goes beyond kind of what you can get by just sort of statistically making up text. It's in a sense that sort of the divergence that happened between kind of the time when people were mostly talking about things in sort of philosophical textual terms, at the time when sort of formal mathematics got started, particularly from the 1600s and after that, where sort of this formal, more mathematical tradition, now the computational tradition, where one's really talking about these kind of precise types of big towers of formal structure, is rather different from what you get by just talking about the sort of statistics of text and so on. So the question I think was also asked about generative images, and that's a place where one is doing the same kind of thing. One wants to make an image that is sort of statistically similar to images one's seen before, but it is generated, for example, from a prompt, and you associate textual prompts with images because there are images with captions on the web and so on. You can kind of forage all of those things. And then you're generating something which is sort of statistically what you would expect to be associated with one of these prompts. But you're generating something which has never in detail been seen before, but it has the right kind of texture and statistics to correspond to an appropriate image. And so I think the question which was asked is what will be the most disrupted by these kinds of technologies? You know, I think there's a lot of places where one wants something that will attract a person's attention, whether it's an icon to put at the top of a blog post or something, that's some kind of striking icon that has visuals that are sort of associated with the blog post, where one might generate that automatically. Whether one's got, you know, a card one's sending somebody, where it's got an image on the front of the card, where one just wants to have a nice, interesting, emotionally appropriate image, so to speak, where the real meat of the thing is what one says inside, for example. Similarly, when one's having text, you know, where it's kind of an introduction, where one's kind of like, hi, so-and-so, and there's some small talk, so to speak. And then maybe there's a main delivery underneath. Or even there's a place where one's describing something sort of personalized to a particular individual. And I think, you know, I'm certainly expecting that some fraction. I just learned actually that one thing somebody sent me at over the holidays just now, which was a card with a nice image and text inside it, was completely automatically generated. And I did not know that. And I thought, boy, this person's gone to an awful lot of trouble, perhaps more trouble than they should have done, to produce this card for me. And you know, in fact, it was completely automatically generated, but still had sort of a kind of a relevant human message, so to speak. So I think this idea of sort of connect to the humans, is a, you know, this is something which is, these are sort of a user interface, another level of user interface of things to be comfortable for use by humans. I notice Luis is commenting that an automatic nonsense falsity detector would be an interesting tool to have. Yeah, well, so some of what one can do with Wolfram Alpha is, you know, you ask ChatGPT to ask, you know, what are some facts that you could check in this essay, and it'll spit them out, and you just feed them into Wolfram Alpha. And Wolfram Alpha may not know those particular facts. It might be, you know, you're writing a fictional essay, and the facts are something that is completely fictional. and was intended to be fictional. So then Wolfram can't help you. It can't fact check something that is a fictional fact, so to speak. But when it's some actual fact about the world, it'll have a decent chance to be able to check that, particularly if it's a slightly more quantitative or definite or formal fact about the world. I think, it's certainly quite the idea of having sort of a signature of AI-ness, so to speak, to a piece of text that's been produced. Well, the whole notion of let's make text that's statistically similar to text that's already out there kind of goes against the idea of let's have something about that text be distinctly not like the text that humans have written. Kind of the whole idea of the training of something like ChatGPT is to make human-like text. Now, you can certainly imagine if somebody said, well, we want to make sure that you can tell, that the recipient of the text can tell, that's got a stamp on it that says, I was made by an AI. There's this whole technique of what's usually called steganography, being able to sort of hide messages and things like text. So a very trivial thing would be, you put a different number of spaces after periods in different parts of the text. Maybe it's one space after the first period, two spaces after the second period, one space after the third period, and so on. And that's something where by pure chance, one wouldn't get 1, 2, 1, 2, 1, 2 number of spaces after the periods in a particular document. And it's very unlikely the person would have made the inconsistency of doing that. But you could then you could detect that particular pattern and say, oh, that was AI stamped, so to speak. Once in the case of that particular pattern, once you know that the pattern is there, you can obviously fake it easily enough. But there are more subtle things one can imagine. And the way that ChatGPT works, I think it's quite feasible to have something where you can inject into this process of picking tokens, you can inject things that at least with high probability would be a giveaway that this was an AI-generated thing rather than something that was sort of direct human, so to speak. So I think it's something where you have, I'm sure this will come, people saying, no, it's really, it's human generated. Oh, it's AI generated. Oh, it's a human in the loop. Oh, it's, many different gradations of how much humanness there was. I mean, it's kind of like you get the AI to produce something and you look at it yourself and you say, I approve this message. Or you say, that's one version. Or another thing is, you write the text yourself, but your English is a little bit messy and your grammar isn't quite right. And then you tell the AI to clean up your English. There's everything between those two extremes and probably more beyond will certainly happen and be useful. And I think, if you ask the question, what will things like ChatGPT be useful for? It's completely clear that, for example, cleaning up slightly messy English, turn these notes into nice flowing text. That's a clear kind of thing that it's likely to be good at. I think I'm looking forward to training one of these things on the many millions of emails that I've collected over the past few decades. And I probably will get to the point where I can generate an email based on just a few words of notes. I mean, it's kind of like what I might do if I'm asking somebody else to send back a response to something. I'd write a few notes and then say, turn this into an actual email that you can send. So I think I'll be able to automate a large part of that process. Now, the interesting question is, what will the footer say? I've had a footer for things for emails that I might send that were dictated to a phone. I've had a footer for years that basically says this was, I don't remember what it says anymore, but basically says this was dictated, because the fact that if you know it was dictated, then if there's some completely crazy word in there, you kind of have an idea why there was a completely crazy word in there, and it doesn't seem as it's not as incomprehensible. And so similarly, there's no doubt be a footer saying, this was this was generated by an AI. It's just like back in the day when people used to have typewritten letters, and somebody would have their assistant type the letter, and then they would have a little notation at the bottom that was indicated that the letter was really sometimes typed by, sometimes written by the assistant, and there'd sort of be a notation at the bottom that indicated that. And I think that's the kind of thing we're going to have to invent the conventions for sort of AI assisted, AI written, AI first, AI second type pieces of text. Let's see. The comments here are from Krista about generative images needing to be able to recycle its output for incremental improvement. Yeah, I mean, what one can certainly indicate this is an area that one likes, this is an area one doesn't like, regenerate the area you like, you don't like, et cetera, et cetera, et cetera. And that is providing additional training for these systems. And in fact, in the case of ChatGPT, my understanding is that there was a bunch of sort of reinforcement learning. Once the thing was basically running, then there were a bunch of people who were like looking at chats that it generated and saying, I don't like this piece, I don't like that piece, that part is great, et cetera, et cetera, et cetera. And I think, when ChatGPT ends up having a very definite point of view about some controversial topic in the world, some part of that is no doubt the result of that last stage of training that was associated with having humans actually look at these at sort of chats and poking at those particular kinds of things, rather than the big mass of training that came from the web, where it's kind of, I mean, there may be all kinds of crazy controversial things associated with the mass of material on the web. But I think the more obvious ones will come from the actual sort of reinforcement learning stuff that came sort of closer to the end of the process. There's a comment here from Krista. ChatGPT will edit your emails into publishable books. Okay, so I'm trying to work out how I'm actually going to train one of these things. The first estimate I have is that I have 15 million words of email that I've written, that I have in my archives. And in terms of things like even these live streams and other kinds of things I've done in the last just couple of years, there's 7 million words of me yakking about different kinds of things. So that's a reasonably decent number of reasonably decent amount of training data. And I suspect from that training data, it will be possible to make something that will, at least locally, be able to generate text rather like me. And whether, I've seen somebody sent me a complete book on some particular topic written by ChatGPT in the last few weeks. It's a little bit bland. It's a little bit kind of same old on every page. And it's kind of like, I can imagine books like that, well, I mean, I've seen books that are sort of formulaically written for like decades. People have had these things where they're sort of computer-generated books. I know there's a series of these things, thousands of them, that were about various kinds of data, where people just sort of somebody just formulaically produced all these books. And they get kind of dull. I mean, it's the same. I mean, I would say that ChatGPT does better because it keeps on injecting kind of these random facts about the world. Sometimes they're true, sometimes they're not true, but it kind of juices things up a bit rather than just the pure recitation of fact. Spare Parts is commenting, if you ask ChatGPT about what kind of human filtering was used to limit its output, it gives interesting answers. I think I've tried that. I think it wasn't very good at self-answering, but it changes every day. Okay, there's a comment from JR here. Can you please do a live ChatGPT coding session live stream? That'd be fun, actually. And I'm almost in a position to be able to do that. Let's see. Ark is asking, what are some of the most interesting prompts you've come up with that can aid in everyday life? Humph. I mean, I've been having fun putting in all kinds of weird prompts. and trying to understand the science of what's going on. Is there anything actually useful to me that I have put in? I mean, you know, thankfully, I'm not a person who typically has to write a lot of just, you know, text for the sake of text. You know, I'm not doing, I don't know, some kind of compliance filings. I'm not doing some kind of legal thing. I'm not sending in, you know, sort of, you know, just sort of things where you need. I mean, I sort of, you know, I kind of feel a little bit sorry for people who have to receive, you know, I don't know what they are, you know, things coming in to complaint bureaus or this or that or the other, where you know those things are going to be machine generated and people can just generate gazillions of these things. And by the way, to this point about whether it will be detector or what's machine generated, the answer is ultimately no. It's going to be a sort of arms race of, oh, there'll be detectors for this and that. Oh, there's a new system that is that's kind of you know, that evades that particular detector and so on. I think one of the issues is the current ChatGPT has 175 billion parameters in it. It's a pretty big system, and it took I don't know, some fraction of a year to train, I think. It's you know, it's a fairly big thing. It was fairly expensive to train, et cetera, et cetera, et cetera. There's sort of that, in a sense, is a protection against kind of the rapidly looping arms race of, oh, we'll make a detector, oh, we'll make a new system, et cetera, et cetera, et cetera. But I think that whatever difficulty there is, you know, this was a high wire act for now, but it won't stay such a high wire act. I mean, you'll see probably even in the next few weeks, you'll see other companies coming out with things that are sort of somewhat like ChatGPT. There have been attempts before. ChatGPT was a better piece of engineering than the previous ones. And you know, didn't fall into some of the messy traps that had existed before. But you know, I think this is a kind of thing where the difficulty of producing a system like this will decrease, and that will mean that this kind of arms race between the is it AI, is it not, will get progressively more difficult. And I think it's kind of thing where you have to expect that you know, that society will adapt rather than there will be a technical solution. I mean, it's kind of like, is this a form letter or not? And you know, there was a time when, well, even when I was a kid, when, you know, most letters were handwritten kinds of things, or maybe typed on a typewriter. Maybe you used carbon paper to get one copy of them, and you could very clearly tell there was a copy versus the original, to a point where you have laser printers and so on in the 1980s and such like, where you can just churn out as many copies as you want. Even with changes where, you know, you say, dear so-and-so, as opposed to dear somebody else. And, you know, each one of these things you might have said, oh, everything will collapse because people won't be able to tell whether it was a letter specifically for them or a form letter or whatever else. But somehow things adapt to it. And my guess is that will happen here as well. You know, I do think that in a sense, the fact that another thing, the writing of sort of generic text, has now sort of fallen into the automatable domain. In a sense, every time one of these things becomes automatable, it makes one, the things that are sort of specific to humans and that require us to have sort of our actual set of sort of human-defined goals and things like this, that aren't just generic, that are specific to a particular human or whatever else. I kind of think that in some sense enhances kind of the value of individual humans and so on, to know that, oh, this generic stuff, it can just be done automatically. It's the special stuff that that can't be, and that's kind of it kind of sets that further apart than before. Let's see. Nightmare comments. I've used ChatGPT to help me give me ideas for movie scripts. That's interesting. You know, I do think that I suppose I've tried using it a couple of times now as a sort of generalized thesaurus. So occasionally I'll be like, what's the right word for that? and I'll use a thesaurus now, an online kind of machine learning based thesaurus. And this is kind of a generalization of that. And I can imagine for things like making up potential names for functions in Wolfram language, I can imagine that it's useful. I tried it a couple of times. It wasn't super brilliant on the times I tried it, but it seems like it could go in the right direction there. Let's see. Couldn't a false detector be used as a way to make the output of ChatGPT actually be coherent? Isn't the detector just the necessary component for ChatGPT to learn from its mistakes? Well, yes, it certainly helps. You can certainly make a training loop where this particular problem will be resolved. The issue is, I don't think it's realistic for a system with this kind of architecture to ultimately learn like how to do some complicated mathematics style algorithm. It's just not going to do it. There are things it can do. I think I now understand reasonably well sort of how it works inside, and it's a fine thing, and it's this big statistical mushy thing. It's not something where it's going to be able to suddenly construct from those things a this precise algorithm for doing something. It can do a lot of stuff, but it's going to be always saying, well, I've got my way of kind of thinking about and approximating this, and it's not going to be this thing that is a sort of precise computation that can build forever. So Gordon is asking here, how could a language model be integrated with symbolic system? Well, for example, in Wolfram Alpha, we're doing natural language understanding, turning things into our precise symbolic form. One thing that we've wanted to do for a long time, we've done many experiments with machine learning, and maybe these large language models will do it significantly better, is if you ask a question that is pretty close to something Wolfram Alpha can deal with, but it needs a little bit of transformation, possibly using, in a sense, real world experience to make that transformation. We haven't been able to do that. And so, in a sense, Wolfram Alpha, with its natural language understanding, provides a big catchment area for things that are sort of modified kind of natural language questions. So that's an example. And what I think you'll see happen if you look at Wolfram Alpha Notebook Edition, for example, where you're using natural language input to define a series of different operations. So you do one operation, you take that result, you do another operation, and so on. I think there are really interesting things that can be done by being able to take those operations and have them be kind of textually defined. And for example, you can go even further than that, and you can say, oh, I'm trying to understand some data from some company or something, and oh, the company has tons of internal documentation, which I can't be bothered to read. But if I were only to read it, then I would probably know that column 7 of database such and such is the number I want if I am trying to compute this. And I can imagine that with kind of GPT type technology, that one could read all that material, be able to ask the question, what column is this in? It will be able to correctly determine that. Then one can use that precise fact, sort of caught by kind of a Wolfram Alpha style natural language understanding interface, turn that into symbolic language, and then go off and actually compute with it. Now, there's a much more extreme version of this. If it's true that there's some kind of theory of thought that is associated with these sort of patterns of semantic flow, if that's the case, one can extract those kinds of primitives of the kind of theory of thought and make them into a symbolic language. One might say, something like logic, where you have, syllogisms like all men are mortal, Socrates is a man, therefore Socrates is mortal. That sort of pattern, which is we can think of as a linguistic pattern initially, that sort of pattern we encode in logic. We then extract the logic from anything to do with words, no Socrates, no mortals, etc. It's just logic. And then we build this huge tower that takes us to a lot of modern digital computing, just on the basis of that kind of formal structure. Now, if there is a similar formal structure that captures some essential feature of kind of the flow of meaning that humans use, then that's a thing where we can expect to extract that sort of essence of what's going on, turn it into something symbolic, and have a kind of powerful way for developing reasoning about, however you think about it, things that involve meaning. I mean, there are other examples than logic. There are quite a lot of other examples where we've abstracted, and a lot of things we've done in building Wolfram language, we've abstracted from the kind of the everyday usage. We're talking about, I don't know, things to do with time, or things to do with, I don't know, all sorts of things about sequences and so on. We've abstracted from those things, made a formal structure that is a kind of a formalization of some kind of everyday type of thing, and then we're going from there. Another thing I should say is that thing we've been interested in for a long time is code assistance, being able to make more likely to be correct Wolfram language code. We've done a bunch of experiments. We'll see. I think some ideas from large language models are likely to be useful for that. I'm more skeptical. I think making small fragments of code described linguistically, which is what we've been able to do for a long time with Wolfram Alpha and so on, is potentially fairly useful. The thing that's been proved very useful over the last decade or so is being able to, for example, describe entities in the world that we can represent symbolically, but describe them in a natural language. That's been a very useful mechanism. It's been a little less useful to explain sort of program operational fragments that way, but maybe it will become more useful as the size of fragments one can deal with increases a bit. That's asked, do you think the ChatGPT is overhyped? And comments that apparently Chomsky was talking about 60 years, he said, we're on the verge of an AI revolution. I don't know. I think, I don't know. I don't know what level of hype ChatGPT is really getting. It's a very interesting thing. It's another, look, it's a moment where what used to be thought of as purely human is now clearly automatable. And the previous iterations, even GPT-2 was much significantly less convincing, really not that useful. I wasn't that interested in it. It's really a surprise how well, and it's also a tribute to some good engineering done on ChatGPT, that it is usefully good. Now, I think people found when Wolfram Alpha first came out, same type of thing. It's like, oh my gosh, it's not impossible to do that. I remember showing, I think I've told this story a couple of times in this live stream forum, but when Wolfram Alpha came out in 2009, I happened to run into a person I knew quite well named Marvin Minsky, who was a sort of longtime AI pioneer. And so I say, Marvin, we built this thing. It's a question answering system. And it's like, let me show it to you. He looks at it for about 15 seconds, and then it's like starts to talk about something different. And I said, Marvin, you should look at this more carefully. This time it actually works. And so, okay, so he tries typing some more things in, and after 5 or 6 queries, it's like, oh my God, it actually works. And then he's like super excited and telling everybody else at the event that we were at, you got to look at this, you got to look at this. So it's one of these things where there's this point at which things get to be sort of humanly useful, and we got to that point with Wolfram Alpha for this kind of question answering, and I guess Mathematica got to that point back in the day, 5 years ago now, of people had thought, oh, you had to do and that initially kind of mathematical computation, that was a domain of humans type of thing. And there's this whole series of different kinds of things where it looked like that was human only. And then it was like, no, actually, there's a credible piece of automation, piece of AI that can do that. And this is the moment where that's happened for essay-like material and other things like that. Now, and there are things that, this is a human interface, so to speak. That is, when you say, I don't know, put in this, describe this thing to somebody. You could say bullet point, bullet point, bullet point, specific things, but the person probably wouldn't understand because they need too much context. And it's like, like it notes that I would make that might turn into some, I don't know, piece of mail that somebody writes somewhere. They've worked with me for a long time. And so my, 3-letter acronyms for things make sense to them. If I were to send those 3-letter acronyms or whatever to the final recipient of the piece of mail, hopeless. They wouldn't understand what I was talking about. But this is, in a sense, a piece of human interface. The human starts off with some kind of prompt, write an essay about this. And then in terms of communicating with another human, this contextualizes that and gives one sort of the full blob of text. And that's, I think, how that's, why that's useful. And I think it's an important thing. And I think it may even tell us some really quite fundamental things about how thinking works. And that's, that's sort of exciting. Okay, maybe one or two more things, and then I actually have to go to, let's see. William is asking, instead of training on text, wouldn't training on sensors that we use, such as video and audio, be better? I suspect that a model that can predict the next video frame will be as intelligent as a human. Video contains text inside itself, and so on. Yeah, I mean, there are attempts to predict, the next frame in a video, and that's that will come, no doubt. I don't know exactly what that will be like, but eventually it will be, this video was made by an AI. We've clearly got to the point where static images can be made that are pretty interesting, pretty, convincing. There are plenty of images where you say this is an image of a face and it looks just like a face, but it isn't any particular person's face. It's some statistically generated mashup of a large number of faces. Yeah, I think this is a thing that happens. Now, I just want to say one last thing perhaps here, which is, does one know when these things are going to happen? And the answer is no. And even the people who are building them don't know. When we built Wolfram Alpha, I didn't know it was going to work. I didn't know how well it was going to work. I know that in the case of ChatGPT, the same is true. Nobody knew how well this was going to work. And nobody knew at what point the threshold would be passed. The same was true with image identification. Telling this is a picture of a cat versus a dog and so on. That was a threshold that was passed around 2011. And similarly with speech to text or with language translation, there are these thresholds that get passed and nobody knows. The people working on these things, by the time they've done tests, they know. But at the point where it's just like, we're going to put in another 4 layers and we're going to increase the length of these vectors and so on, and is that going to finally do it? Nobody knows. And it's so when you ask me how soon will we be able to make a good video automatically, I don't know the answer to that. I don't think anybody knows the answer to that. When it happens, we'll know it happened, so to speak. As we sort of keep pushing further, it will eventually happen. I think that one, like the text, I'm surprised the text one happened now. I didn't based on sort of the progress of things that came before it, it did not look like it was really close. It looked like it was pretty crummy still, and there was this real jump that happened, that happened going from tens of billions of parameters in the model to hundreds of billions of parameters in the model. And it's kind of a funny thing. I mean, maybe it's because, we all have about 100 billion neurons. Maybe that's not unrelated to this fact. I think it's also the thing that is worth realizing is, one thing ChatGPT continues to put nails in kind of the coffin of or something, is the idea that brains have something completely ununderstandable to us in them. it's really looking like, with every passing kind of AI achievement, that there's less and less that is, oh gosh, brains, dip deep into quantum mechanics in ways that we completely don't understand to achieve the kind of thinking we achieve. No, it's something that is really looks like it's very representable at a formal computational level, and it's really just the size of brains is sufficient that that they do complicated things. Barry is commenting here is the fact that I do things like log all the keystrokes I type and so on, have the expectation that I can feed it into an AI and it'll understand how I think about stuff and so on. Yes, that thought has certainly occurred to me over the course of the last third of a century or so on, that I've been recording all this stuff about myself. I've certainly had this idea, one day I'll feed all this material into some kind of AI system and it'll be a bot of me, so to speak. I have to say, I wasn't thinking that was all that realistic anytime soon. And I was been kind of thinking about training various language models and so on email and so on. And now I'm highly motivated to do that because I think it's actually going to work for some purposes. Whether, in what sense it will be possible to kind of, this idea of deducing thought processes, you have to have a representation of those thought processes. To say, well, there's all these bits and they're flapping around in this way is not something that is a sort of human narrative, sort of scientific type theory. That's something where you're just saying the thing works because it works, so to speak. The thing works the way it works. And you're not abstracting from that something higher level. Whether it's possible to abstract something higher level and say, oh, the way that I think is by making these connections in this way, et cetera, et cetera, et cetera. Interesting question, whether that's going to be possible. I will say, I think I've said this before, that one of the things I will do expect is that sort of as these large language models and so on get even more large scale, although they've used most of the training data that is readily available by now, and they have to sort of train on what they're themselves doing and so on at this point. But the ability to make these kind of big analogies between very different domains of information and so on will, I think, be a thing that comes. Oh, I'm making this poetic or scientific analogy between something that happens in biology over here and something that happens in economics over here, for example. Being able to make those connections because you can kind of tell that the patterns of what's going on are the same. I think that's something that will come. And it's something that will be a bit shocking to us humans because some of those things are pretty hard for humans to do, partly because humans just don't know as much. Humans know about something in a particular domain, not about across all these domains. And I think that may be one of the things that will be the most kind of shocking to people is an ability for sort of the AIs to jump from domain to domain. I think that's already something where if you look at Wolfram language and you look at what's happening inside that, a lot of things where we're able to compute stuff. If you're an expert in that particular kind of thing, it's like, how on earth are you able to compute these things? Well, the answer is because we're using a lot of different domains of knowledge, sort of all connected together in a coherent way to be able to do that computation. All right, I should stop here. Thanks for those comments, questions, and maybe I should do a specific one of these live streams about generative AI and so on. Since it seems like there are a bunch of questions about this. Oh, I noticed one comment here. Ark says, I've used ChatGPT to construct a 365-day nutrition plan, and they're just having their first breakfast based on it. Good luck. Let's hope we don't find out that I hope not too many people do too many dramatic things based on, oh, ChatGPT told me to do this. That will be an interesting excuse structure. Anyway, all right. Well, thanks for joining me and see you another time. Bye for now.